Yeah, this is.
Yes.
So, good morning to one and all present here. We are from VIT, and this is our paper title, that is SKIDS and Object Classification and Smart Communication Based Waste Bin, and our paper ID is 3066. Myself, Shomo Roy, along with my co-authors Shriya Chaudhary, Dishanvita Ghosh Chaudhary, Srijit, Khyati Priya Jain, and Budhaditya Bhattacharyya will be presenting. So, moving on to the agenda of this meeting, initially I will go through the abstract and the introduction, followed which I will talk about the literature survey where we have referred a few papers for our project. Then I would talk about the proposed methodology that we'll be referring for our paper, and also I'll end the meeting talking about the results, conclusion and the references. So moving on over the abstract, we basically have worked on an IoT based smart bin which uses modern machine learning based object detection techniques like YOLO V8 framework, and we have also used a novel communication protocol called PyFormatta to implement Python on Arduino boards to classify waste into plastic and non-plastic and to segregate them accordingly. Then we also use Bluetooth Terminator app to thereby indicate to the user whether the particular how waste has been detected and to what level the bin has been full. And after that, I will also touch upon the performance metrics of our machine learning model that we have used. Moving on, what is the background behind our project? So according to the Central Pollution Control Board, there are millions and tons of waste generated every day of different kinds. But the biggest problem that exists even today is that the waste are not segregated properly into plastic or non-plastic, and this causes a lot of health issues and also environmental contamination. So thereby in our research paper, we propose a project on which we have worked on a machine learning based smart dustbin using YOLO V8 to classify waste into plastic and non-plastic and to dump them accordingly with higher amount of efficiency and accuracy. So here we have referred few papers with the existing hardware architectures using Raspberry Pi, but what we happened to realize was even though these projects already exist, none of them have been accurately able to segregate plastic and non-plastic and dump them in a efficient and accurate manner. So thereby, I would like to propose our methodology where we have divided it into two parts. The first part is the software methodology and the second part is the hardware methodology. So in software, what we do is we have a webcam which captures frames for 20 seconds, and after that we process these frames, and after that, after processing, we give a output whether the particular object detected is plastic or non-plastic, and if the particular object is detected as a plastic, we rotate the plate by 90 degree, dumping the waste on the left side of the bin, and if the particular waste is detected as non-plastic, we rotate the servo motor by anti-clockwise direction in 90 degree, and thereby we dump it on the other side. So thereby moving on to the hardware methodology, we have used an ultrasonic sensor to determine the level up to which the bin is full, and after that we have also used LCD and LEDs to indicate the level at which the bin has been full. So using the ultrasonic sensor we get various distance values, and after analyzing those we can say that if the distance is between 0 to 10 centimeter, we would say to empty the bin, and and if the distance is between 10 to 20 centimeter, we would say that the bin is half full, and if the distance is between 20 to 30 centimeter, we would say that the bin is empty, and if nothing is present, we would say that the bin has not detected anything. So moving on to the system architecture, we have a webcam here. This webcam detects any kind of trash, let's say a bottle, plastic bottle or something kept here, and after that this webcam captures the frames and thereby asserts that whether this is plastic or non-plastic, and thereby there is a servo motor present beneath the plate which moves left or right direction depending on the detected garbage is plastic or non-plastic. If it is non-plastic, then it would be dumped in this direction. If it is plastic, it would be dumped in the left direction. And we also have indicated the status of the bin using the LCD present here and the LEDs present here. So moving ahead with the results, this is our software results where we have used YOLO V8 for training our model, and thereby this is the validation dataset where we can see the chips packet, where we can see various pens that we have kept here. Also, we have also used various performance metrics like the F1 score, precision recall curve, precision curve, and recall curve. The area of the precision recall curve came out to be 0.913, and this is where high recall and high precision comes to an important part so that low negatives can be detected. And after that, in the precision curve, we have detected a precision of 0.94, and in the recall, we have found a value of 0.85 for the convergence, and the maximum F1 score we found it as 0.9. Now moving on to the hardware results, we first detect the bottle. As I told, we kept on a trash plate and it gave us an accuracy of 0.98. And after that, we dump it on the left side since it is detected as a plastic waste, as we can see here. And according to the status of the bin, in the LCD we display an output as either the bin is empty, half full, or full. And in case the bin is full, we also send a message to alert the user using the
Okay.
Bluetooth serial terminal app where we
Yes,
say the
sounds
bin
good.
is
So
full.
you can conclude it.
Yes, sir. So I also had a video
No,
to
it's
show,
okay.
by the way.
Okay.
So
Okay.
can
So
I
you.
just conclude?
Okay. So listen. About you said the segregation. So can
Yes, sir.
you do this? Implement this for dry and wet waste like that?
Yes, sir, we can do it. We'll have to train our model again so that
But
we
for
can
dry and
classify.
wet waste, like there is a moisture. So how you can able to evaluate the moisture? That can't be done with the webcam.
Sir, that's what. So here we have put images of specific items, right? For let's say a plastic packet, let's say it's a dry waste, and wet waste can be, let's say, this banana peel. Okay, sir.
Mhm.
So this banana peel we can put under the wet waste category, and we can put images in our testing uh, dataset in such a way that we are putting wet waste in a large quantity so that we can accurately train our model to detect this particular wet waste. And we can also put a aluminum based, let's say, plate or something here so that the moisture content doesn't create any kind of fungus on the plate. So this is one thing we can aim for
Okay,
the
like
future
just you have taken
perspective
it
of the
for
work.
one image. Okay, like if now say the bin is like half. Okay, and there are multiple images like getting it. So and if the waste is like it got mashed up, so how it will get able to segregate efficiently?
Correct. So in this case, we also have a third mode where we say that the particular waste has not been detected as a plastic or a non-plastic, no detection found. So when we have a no detection found, in that scenario, we'll inform the user stating that the garbage has not been detected appropriately. We
Okay,
would
and like
alert the user and we
this
would request him to,
yes.
segregate it accordingly.
And this data about the dustbin full half or like you are you're sending it to Microsoft Azure like to some remote location or to user or like what?
So we send it to Bluetooth.
Okay, you're sending it to Bluetooth.
Yes, sir.
The Bluetooth range will be less, so the like any other appropriate option.
Yes, sir, but as of now, our components are also close to each other, right? So we did not
Okay.
face the issue of a distance.
Okay. No, but practically, if I want to implement that,
Yes, sir, as a future scope of the work, we do want to implement Wi-Fi and cloud-based RFID-based technologies where we can show the use our where we can, let's say, store the data on a cloud and thereby alert the user, telling them that the particular bin has been
okay,
full or not.
okay,
So
okay,
as a future prospect of the work, we also want to include the email and those Wi-Fi based techniques. As of now,
okay,
we were developing a more of a proof of concept (POC) of a more accurate
okay,
segregation model of plastic and non-plastic.
okay, sir.
Sir, I have results video. So do I show that or?
Yes, yes, just show the video.
Yes, sir. My name is Shomo Roy, and I'm a third year student pursuing BTech in EC at VIT Vellore. Here in our system, we have two scales, one placed in a vertical manner and one in a horizontal manner. On the vertical scale, we have two Arduino boards. One is an Arduino Uno, one is an Arduino Mega, and we also have a webcam placed here. On the horizontal scale, we have a breadboard with three LEDs, a LCD along with a Bluetooth module. Underneath the scale, we also have two servo motors which are attached along with a cardboard plate. We also have an ultrasonic sensor, and we have also put two plastic bags to denote plastic waste and non-plastic waste.
Hello, my name is Shreya Chaudhary. I'm pursuing BTech in Electronics and
Okay, okay,
Communication
okay.
at VIT.
Yes, sir.
So as you were saying, now see how can't you make an app to just app or like take it into
Okay, sir.
cloud and
Yes, sir.
upload and like
Yes, sir. So
yes,
coming to what you're saying, sir, can I present?
yes, yes.
Sir, this output which you're seeing, this comes from a particular app which is called Bluetooth Terminator app.
Okay,
Sir, so that app already shows with the help of the Bluetooth this particular output whether the bin is full or not. But sir, talking about the future perspective of work, as we have referred from the one of the papers here, there is an app called Blink app, and we can use that in the future to show the status of a bin in a more accurate manner using Wi-Fi and cloud-based techniques, like implementing Microsoft Azure to, let's say, send data regarding the status of the bin.
okay, okay, okay. Thank you.